section 9.3, extra example number 9, construction zones. We're asking if we can conclude the average speed of drivers is greater than the 25 miles per hour speed limit. So in your state, please get used to defining what mu is. So for means, okay? So we're going to let mu be the true mean speed. True mean speed. You must define that. Otherwise, writing h naught and h sub a just doesn't mean anything if you don't even define what mu is to begin with. So mu is the population mean, true mean speed of drivers in this construction zone. So we'll just say true mean speed of drivers. So we're going to do a test. We're going to assume the null hypothesis is true, meaning that mu is equal to 25. But we want to show, is our alternative hypothesis, that mu is greater than or less than or not equal to? Greater than, yes. Because we suspect that speeding is happening. Greater than 25. And we're going to, it doesn't say this, but we're going to perform this test at the 5% probability level. So at alpha is 5% for our significance test. And you can, if it doesn't say one, you should use that. Okay, so our plan is, you should know the name of the test. So what is the name of the test? One sample T test, yeah. So as opposed to an interval, you'll need to know that on the test if it's multiple choice and it says like what test are we performing. You should know the name of it. Everything is a one sample. It's T because we're doing means and we don't know the population standard deviation. So it's a one sample T test as opposed to an interval. Last chapter was confidence intervals, so it's test. Perform that if our three conditions are met. Number one, a random sample of drivers was selected. Number two, we have to look at the data because we have only 10, sample size is 10. So n equals 10. So but box plot shows only slightly skewed left, no outliers. And I'll show you that. So we'll type these in and we'll do a little sketch. So we go to, we're going to need to type it in anyway, so we go to stat edit and we type in 27 and 27, 33, 32, 21, 30, 30, 29, 25, 27, 34, and then we go to stat plot, turn it on, go to the one that shows the outliers, the box plot, enter, hit graph. No, it's not showing, so hit zoom 9 and it'll size the window, zoom and 9, and there we go. So the side that's sort of stretched out that has is where it's skewed. The more extreme values are to the left, so it's slightly skewed left. And I don't see any outliers, so we don't even have to do the computation. So we're okay to use this test, and it's independent because there are greater than 100 drivers. So we've shown all of our conditions. So we're going to do, and so we need the sample mean and standard deviation. So on your calculator, you go to stat calc 1var stats, make sure it's the right list, calculate, and there's our mean and standard deviation. So x bar, thank goodness we don't have to do this by hand. X bar car is 28.8 miles per hour, and standard deviation is, on average, the values vary from the mean by 3.9 miles per hour. So then we want to figure out how far away our sample was from our population mean stated in H naught. How many standard deviations away was it? Okay, so we do our test statistic T equals 28.8 minus the mean stated in H naught over 3.9 over the square root of sample size 10. Carefully type that in, and we get it's over 3 standard deviations away. So that's, we're probably going to be able to reject. That's unlikely, over 3 standard deviations away. But we need to figure out what the probability is. So the probability that T is, and we want to go greater than, because that's the direction that we're going in our alternative hypothesis, greater than 3.05 with how many degrees of freedom? 9, good, degrees of freedom is, and I'll show calculator I'm going to use this time, TCDF. So I'm going to go, remember the left bound goes first and then the right bound. So we want greater than 3.05, so we go from 3.05 to infinity, and our degrees of freedom goes right there. And you will get a very low probability, small area, and that's a 0.7% chance of that happening. So we don't think that the null hypothesis is true. So our conclusion, be sure you have this in your conclusion. This is, the first part is the formula. Since the p-value is less than alpha, we reject H naught. That's the shortest way I can say the null hypothesis. But then you have to interpret in context. So what does that mean? There is convincing evidence that what? The drivers in the zone, in the construction zone, are going faster than 25 miles per hour. The conclusion is very important. So now let's talk about, let's use what we learned from Amit on the type 1, type 2 errors. So what sort of error could we have made, type 1 or type 2, and then what does that mean? So we ended up rejecting the null hypothesis, right? So which one is that, type 1 or type 2? Yeah, type 1, right? So we could have made a type 1 error because we rejected the null hypothesis. So we could have made, and what does that mean? So we could have made a type 1 error, which means, so it means we rejected H naught in favor of H sub A when H sub A was really not true. So meaning we mistakenly what? Mistakenly concluded that they are going faster than they really are. Are going faster than 25 miles per hour when they really aren't. When they really are not. So that would be a type 1 error. You know, and the consequences might be that we waste money on putting speed bumps out there when we really didn't need to.